Okay, 8.2 is all about exponential decay. In 8.1 we had exponential growth, which means that you were moving at a more and more extreme slope the further that you got away from the asymptote. This time for exponential decay, we're going to be going at a slower and slower pace. So you'll see what I mean in just a moment. So example 1, graphing functions in the form y equals ab to the power of x. Okay, so just like it was for the exponential growth, except now our b, oops, let me switch over to the pen, b is going to be less than 1, but is going to be greater than 0. Okay, so it's going to be in between 0 and 1. And what this does is, as x is going to increase, that means that b is going to decrease. Okay, so b to the x power is going to decrease as x increases because it's a fraction being multiplied by itself. Okay, so let's take a look first here at a, y equals 2 times the quantity 1/3 to the x power. So if I plug in 0, for x, so of course anything to the 0 power is 1, so 1/3 to the 0 power is 1, and 1 times 2 is 2. So I get 0, 2, so I'll go ahead and plot that. And then if I plug in 1, so 1/3 to the first power is 1/3, and 2 times 1/3 is 2/3. So 1, 2 over 3, or 1, 2/3. So notice how we got smaller. However, if we continued this and said 1/3 to the second power, so if I plugged in 2 for x, that would be 1/3 times 1/3, which is 1/9, and then 2 times 1/9 would be 2/9. So in other words, we'd be getting closer and closer to 0, but never actually reaching it. Okay, so from right to left, we will draw a curve that begins just above the x-axis. So notice that we're now moving from right to left. Okay, we're going to start just above the x-axis, pass through the 2 points, and then move up to the left. Okay, so move up to the left. Okay. For b, we have y equals -3 times the quantity 3/4 to the x power. So this time when I plug in 0, I still get 1 for my 3/4 to the 0 power, because anything to the 0 power is 1, times -3 is -3. If I plug in 1 for x, that would be 3/4 to the first power is 3/4, and then 3/4 times -3 is -9/4. So I have 0, -3, and 1, -9/4, so -9/4 would be -2 1/4. Okay, so -2 1/4, about there. Okay, again, I'm going from right to left. Draw a curve that begins just below the x-axis, passes through the 2 points, and moves down to the left. Okay, so it begins just below the x-axis and moves down to the left. Okay, and this time exponential growth would get steeper and steeper as you move to the right. In this case, for exponential decay, we're moving steeper and steeper as we move to the left. Okay. So to graph a general exponential form, okay, again we have the same as it was for exponential growth, where we have y equals ab b to the x minus h and then plus k. So in example 2, we have our x minus h happens to be x plus 3, and our k happens to be minus 2. So that means when we get to that point, h is equal to negative 3, and k is equal to negative 2. So that means that we're going to translate 3 units to the left and 2 units down. So we'll get there in just a moment. But just like our exponential growth, we're going to start by graphing the basic portion before it's been translated. So 3 times the quantity 1/6 to the x power. So if I plug in 0, that will give me 0, 3, because 1/6 to the 0 power is 1. 1 times 3 is 3. And then if I plug in 1 for x, 1 times 1/6, let me correct that, 1/6 to the first power is 1/6, times 3 is 3/6, which is the same as 1/2. So we get 1, 1/2. So 0, 3, and 1, 1/2 gives us points right there. And so that would be light. I'm going to lightly sketch that graph, and instead of lightly sketching, I'm going to just use a dotted line because I can't really do light sketching on here, but I will use a dotted line or a dotted curve to represent this. Okay, and again I'm going to approach the x-axis to the right, but not actually touch it. Okay. And now I am going to translate it, and I am going to translate it in purple. I'm going to translate it 3 units to the left, because h is negative 3, and 2 units down. Okay, so if I go 3 to the left, 1, 2, 3, and 2 down, 1, 2, that means that one of my new points is right there, and then 3 units to the left, 1, 2, 3, and 2 units down, 1, 2. My other new point is right there. Okay. Notice that my asymptote now shifts down 2 units as well. Okay, so my new points are negative 3, 1, and negative 2, negative 3 over 2. Okay. The graph's asymptote is now the line y equals negative 2, because we've shifted 2 units down. So the whole thing is shifted 2 units down, so that means that the asymptote is now y equals negative 2. And so we curve our line matches, or our curve matches the other one. We just curve it down, and it approaches but doesn't touch y equals negative 2. The domain, because we can plug in any x value we want, the domain is all real numbers. And the range, so all of my y values must be greater than negative 2, because I have this asymptote at negative 2. So my range is y is greater than negative 2. And that's it.